It is somewhat complex problem, not exactly complex problem. As we said, it is very easiest problem. Just follow through my procedure, right? Okay, first we have to go through your reference axis, x-axis and y-axis, along x-axis and along y-axis, right? Right. As we said in the earlier classes, you please simply divide into number of equal parts. That is the only thing we have to follow, right? Make a convenient number of equivalent parts, or equal part, not equivalent, equal parts, right? That means suitable divisions. You can say that suitable divisions, right? So here is a jet section. I have make it as a dotted lines. Dotted lines 1, 2, 3, right? Whenever you're having dotted line, that part is 3. So first part, second part and third part, you observe clearly. First part, second part and third part we are having, right? Now what is the thing is simple thing. Now simply you can go for the calculation of area of each and every part. So here we are having 3 parts, A1, A2, A3. Now we are able to find out the centroid with respect to x-axis and with respect to y-axis, so that both the centroids are very important. So here for this problem, because it is unsymmetric section, whenever you are having an unsymmetric section, simply you have to find out the centroid with respect to x-axis and centroid with respect to y-axis. Both the centroids are very important here, right? Fine. Now we have to move each and every step one by one. So first you have to calculate the areas A1, A2, A3. What is the area block 1? Area of the block 1. So 20 centimeters and 5 centimeters. 20 into 5, that is 100 centimeters square. Next, block 2, A2. Here we are having block 2 is 20 cent. Those 20 centimeter is up to point 1. That means part 1. But we require only part 2. That means, so simply you have to remove this 5 centimeters. Simply you have to remove these 5 centimeters from 20. So that you will get 15 centimeters up to your block 2. Up to your block 2 you are having 15 centimeters. So 15 into 2.5. That is 37.5 centimeter square. Right? You please understand, those 20 centimeters from top end to bottom end, that means up to the, we are divided up to the part 1. So we require only part 2 block. So part 2 block means simply you have to subtract those 5 centimeters, right? So 15 into 2.5, that is 37.5 centimeters square, right? Next, the third one is area of 3. Area 3 means here you are having directly, you can calculate 10 centimeters into 2.5 centimeters. 10 into 2.5, that is 25 centimeter square, right? So this is how you are supposed to calculate the area of this section. So area wise we are not having any problem, because we are conveniently we divide the number of steps. So part 1, part 2, part 3, right? So it is very important as a, it is very important while you are solving the problem, right? So how many number of parts you are supposed to be divided, and what are the shape of that particular cross section when you are divided. That is also very important. So I already told you that don't go for any complex division. Make it as easy as possible. As easy as possible. That is a very important point you have to be remember. Right. As I said, in the next one, you simply go for the centered about x-axis and centered about y-axis. So first take x1 value, x2 value, x3 value. x1 value for block 1, x2 value for block 2 and x3 value for block 3. Now identify what is the value of x1. So x1 is 20 centimeters. Please understand, this is very important. x1 is 20 centimeter, block 1. x1 means block 1. Block 1 is in x direction, it is 20 centimeters. But reference axis started from 10 centimeters. Please observe that reference axis start from 10 centimeters, but your block is 20 centimeters. That means before that also you are having some centimeters. How much amount of the centimeter, that is also very important. You please observe that this is the block 10 centimeters and you are having 2.5 centimeters also. That means up to the before 20 centimeters you are having 7.5 centimeters. That is also very important. 7.5 centimeters. Before that you are having 7.5 centimeters. So block 1 centroid is 20 by 2, because it is a rectangle block. Rectangle block centroid is exactly at the center. So 20 by 2. 20 by 2 plus 7.5. Why it is 7.5? Because it is started. Before the 20 centimeters. That means the reference axis. Always you have to start from your reference axis. But 20 centimeters ahead you are having some value. Those value you have to find out. Those value is 7.5 centimeters. Right? That is x1. Next, calculate about x2 value. What is about x2 value here? x2 value is also same procedure. Here starting from the reference axis you are having 10 centimeters, it is a 2.5. Block 2 is 2.5 centimeters, centered of block 2 is 2.5 by 2. But before that you are having 7.5. So that 7.5 plus 2.5 by 2. That is the point. Next, again in a block 3. In a block 3, directly, see, observe, 10 centimeter is starting from reference point. 10 centimeter is starting from the reference point, so that it is 10 centimeter by 2 directly. 10 centimeter by 2 directly. So the x3 value is 10 by 2, 5 centimeters. Right. You please observe that in the x1 direction, x1 along x direction. So those 7.5 value get from 10 minus 2.5. 10 minus 2.5. Similarly, x2 value is 10 minus 2.5. Same problem. That means you please observe the figure. So 10 minus 2.5. So 10 value is there and 2.5. That is 7.5 value. Right. So calculate x bar value. X bar value is a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus. Please substitute those values as easily. What we got earlier, so a1 is 100 centimeter square, a2 is 37.5 centimeter square, and a3 is 25 centimeter square. You simply substitute those values as easily. Right, now we have to move from y1, y2, y3. What is y1, what is y2, what is y3? Simple as usual. You please move from top end or bottom end, whatever it is. It is as per your convenience. I always prefer from bottom end. So in bottom end, so block 1 is y. Block 1. Along y direction you are having 5 centimeters. So 5 centimeters centroid is 5 because it is a rectangle block. So 5 centimeter is, it is 5 by 2. 5 centimeter is, it is a 5 by 2. 5 by 2 means 2.5 centimeters as usual, no problem. Next, y2. y2 value means from y1, that means from block 1, y2 is how much distance? That is you supposed to calculate. So first calculate block 2. Block 2 means in a y direction you are having 15 centimeters. You please neglect this 5 centimeters. It is block 1. Block 2 is 15 centimeters. So block 2 value is 15 by 2. It is centroid. Next, it is how much distance from block 1 or bottom axis, right? It is 5 centimeters. So 5 plus 15 by 2. You will get 12.5 centimeters. Next, y3. y3 means block 3. Block 3 means it is 2.5 centimeters. Centroid value is 2.5 by 2, right? Now those 2.5 centimeters from the bottom, how much amount of the distance? That means 5 plus 15. So 5 plus 15 plus 2.5 by 2. That is 21.25. That is 21.25 centimeters. It is y-axis is very easy compared to that of your x-axis, right? You simply have to add those terms and how much amount of distance you are having. Those distances are simply have to add from reference axis, right? Suppose if you move from top end means suppose if you take third block 2.5 centimeters, first one 2.5 by 2, second one it is 15 centimeters, 15 by 2 plus 2.5, third one 2.5 plus 15 plus 5 by 2. Likewise you are having same calculations. There is no difference in the calculation, right? Either you have to move from the bottom end or you have to move from the top end, right? Now calculate the distance, formula you are having y bar equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. That is, the value is 7.69 centimeters. Simply substitute those values what you have got earlier. Those values here and you will get the value of 7.69 centimeters. So how we supposed to calculate this jet section, right? So it is very important. Very important. First, if you learn this jet section, it is very easy for you, especially along in x direction, because x direction some of the students may get confused, right? So always with reference to reference axis, you please remember that always we try to move from the reference axis. If it is ahead of or away from the reference axis, those distances simply have to be added in order to get the, because those centroid values, that much distance also is supposed to be added. So this is very important point. You please remember these points, right? In the next class we are also here onwards we keep on moving by discussing the complex problems, right? Thank you.